So here's what I think you should do on page 18. Over here, about right here, draw this. Now leave about, maybe 2 inches margin over here. A couple inches. And then go ahead and draw your old familiar diagram of meiosis. Like this. The old familiar diagram. And leave, if you can, a couple inches margin over here on this side as well. Okay? All right. So far that looks familiar, right? Obviously you're probably thinking, well, we're going to review meiosis. Yes, we are, but there's more to it. Now I want to layer on more stuff. I want to look at spermatogenesis. So, before we get to this picture here, this cell, we've got to go back in time a little bit. We're looking inside the testis here, okay? So, draw another cell right here, like that. And we're going to have this cell do mitosis to make this cell and another cell just like it. Okay, so this is, I'm going to label this right here. This is a mitosis step right here. So this is a very special cell in the testis, okay? It goes through mitosis to make this cell that's going to eventually do meiosis and make 4 sperms, and then this cell. So this cell splits into 2 identical daughter cells. I think we're going to go ahead and give this cell a name, so let's label it. Go ahead and label it like this. This cell is called a spermatogonium. Okay, here's how you spell it. Spermatogonium. That's a big word, isn't it? That's not a word most people throw around much in everyday conversation. When's the last time you heard somebody use that word, spermatogonium, in the hallway? Never, right? It's a spermatogonium. A spermatogonium cell. You know what this spermatogonium cell does? It goes through mitosis to make another spermatogonium. That's what this cell's called. And this cell is just like it, only we give it a different name because it's going to go through meiosis now and make 4 sperms. This cell is called a primary spermatocyte. That's the name of that cell. Primary spermatocyte. Okay. This cell is diploid. What's that mean? Really?
There's 2 chromosomes.
The chromosomes are in pairs, aren't they? Homologous pairs. Yeah, a real human primary spermatocyte would have 23 pairs. We're just looking at 1 pair, right? There'd be 23 pairs in here. There would be 46 chromosomes in here. It's a diploid cell. And there's a symbol we use to show diploid. The symbol is 2N, where N stands for chromosome number. And this just means that we've got our chromosomes in this cell in pairs. It's 2N, okay? In the computer tutorial, remember the word diploid? That describes a cell that contains chromosomes that are in homologous pairs. It's diploid. Okay. And you know what? The spermatogonium cells, they're diploid too. Hi. Thanks. They're diploid also. Who's this for? Oh, okay. They're diploid. Now, anybody know what's going to happen to this cell eventually? Tell me. I've already said it twice. What's this cell going to do, Laura? Yeah, the primary spermatocyte is going to undergo meiosis. It's going to become 2 cells and then 4, and these will ultimately become gametes or sex cells. Anybody want to take a guess as to what this new spermatogonium cell right here is going to do? Anybody want to take a guess? I haven't told you, so it's okay if you don't know. Take a guess. Sarah?
Is it going to do mitosis?
Excellent! Yeah, this new spermatogonium, when it's mature, it's going to do mitosis and make another spermatogonium and another primary spermatocyte that can make 4 sperm. Anybody want to take a guess as to what that another spermatogonium cell is going to do? Justin?
Do mitosis again.
Yeah, it's going to do mitosis and make another spermatogonium and a primary spermatocyte that's going to do meiosis. You see the advantage? You see the good thing about this mitosis step on the front end here? Because of mitosis on the front end, you keep making new spermatogonium cells, guys. So you never run out of sperm cells. You never run out. Well, until you die. You never run out. 150 million a day made fresh daily. Oh, like donuts. Right? You never run out. That's a real important step. Anybody want to take a guess as to when this activity begins in the testis? When does this activity up here on the board begin? When does it start? When the boy's an embryo, when he's a little kid, but when does it start?
Embryo?
Nope. Doesn't start until puberty. That's when it starts. So in other words, there's not much going on here until puberty. Okay? That's when it starts. And then watch out, it just takes off. You got, hundreds of millions every single day. Now, the primary spermatocyte's going to do meiosis 1, and you remember that, right? Meiosis 1, and these 2 cells are called secondary spermatocytes. Okay, secondary spermatocytes. That's what these 2 cells are called. And then they're going to turn right around and do meiosis 2, like this. Chromatids pull apart. These 4 cells are called spermatids. 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 That's what they're called. Now, what's really interesting about all this to me is whether you're talking about sperm formation or egg formation, the chromosomes on the inside are doing the same dance, the same meiosis choreography. But on the outside, of course, the cells look very different. And we're going to see that when we look at oogenesis in a little bit. Okay, we need to add something to our diagram. These 4 cells now, these 4 spermatids, they're going to shrink down. They're going to grow tails. And then they're going to look kind of like this. They shrink down, they grow tails. Those are called sperm cells. That's how it works. Spermatogenesis. Now, to go from this cell here to mature swimming sperm cells here takes about 64 days for this cell to go to here, mature sperms. About 64 days. I had somebody ask me once, Mr. Ruhl, does that mean you only make sperms every 64 days? No, no. You've got millions of cells in this stage, and millions of cells in this stage, and millions in this stage, and millions here and millions here. It's kind of like, think it's kind of like an assembly line, okay? And these mature sperms are coming off, they're rolling off the end of the assembly line every day. Millions of cells in each of these stages here, okay? Got that? Make sense? Now, I'll tell you what we're going to do. Now go to page 19. Now we're going to look at oogenesis. Okay. Oogenesis, formation of oocytes. Oocyte, just a fancy word for egg cell. And we're going to have to change the diagram a little bit, so don't draw anything yet. Okay. Obviously, in oogenesis, we don't make sperms. Is that like the understatement of the day? Okay, so we're going to erase these sperms. We don't make sperm cells. Erase sperm. We'll erase these arrows here. Okay. All right. And we'll start from the beginning. Now we'll do this. I'm going to change this diagram just a little bit. When this primary cell splits in two, don't draw anything yet. When the primary cell splits into two secondary cells, one of these two daughter cells gets all the cytoplasm, all the nutrients, all the goodies. The other one here ends up just being pretty much a naked nucleus with no cytoplasm around it. Okay, imagine you got this big ball of clay, and instead of pinching it in two equal halves, a small little piece breaks off. And this is that small little piece, and this is the big piece you got left over. There's an unequal division. This one's going to become the egg. We can call it the egg. This one is wasted. The only function of this one is to get rid of half the chromosomes. Pull half the chromosomes out so you can get this cell down to half the number of chromosomes. Anybody remember what word we use for that? Half the number? It's not diploid, it's what? Haploid, right. Haploid. Now, some people also use the word monoploid, and the symbol for that is N. Okay? N, haploid. Half the number of chromosomes. Or monoploid, a cell that has just one member of every chromosome pair in it. So this is going to become the egg. This little cell down here, pretty much just a nucleus, a naked nucleus, is called a polar body. That's called a polar body. It's going to die within a couple days. Okay? This is going to be the egg that we're going to try to nourish along here. Okay, now, we're going to change this diagram here a little more. Sometimes, it's not very often, this first polar body will divide into two, and then they die. When this egg, we'll call it, goes through meiosis 2, it kicks out another polar body, and there's our actual egg right there. You with me? Okay. Here's your 4 daughter cells of meiosis. 1, 2, 3, 4. Right there. 4 daughter cells. But these 3 polar bodies, they're going to die and disintegrate. This is, Claudia, this is the egg. Okay? Now, okay, we have to change some words here. I'm going to erase spermat and put another O in the front of this word. This cell's called an oogonium. So you can go ahead and draw this now, and then label this first cell, this special cell in the ovary, oogonium. All right? That's the oogonium. And that means this one up here is also going to be called, oogonium. And, ladies, you don't make primary spermatocytes. You make primary, let's get rid of spermat here, oocytes. So this is a primary oocyte. Who wants to take a guess as to what this cell is going to be called? Should I use the random pointing finger of doom to pick a victim? I'm volunteer. Angie? You know what this cell's called? It's not a secondary spermatocyte. Yep, secondary oocyte. That's what it's called. So, secondary oocyte, singular. Okay. All right. So, if we rewind just a little bit back here. So here's a special cell in the ovary now, oogonium. It does mitosis to make another oogonium and a primary oocyte. Primary oocyte's the one that's going to do meiosis 1 and make a secondary oocyte, fancy word for egg, and a polar body. Now, the secondary oocyte, if and when it does meiosis 2, this cell is now called an ootid. Ootid. So now we got an ootid and 3 polar bodies. Oh, gotta get rid of this word. Kind of makes sense. Do you see any similarities between this and spermatogenesis? Some things, but there's some things that are really different, right? So you're only making 1 egg here, not 4. You're making 4 sperms, but in oogenesis we're only making 1 egg, and it's called an ootid. Okay. Now, there are also some very important differences in terms of the timing here. When did I say boys start doing this mitosis step on the front end here? When do boys start doing this? Puberty. Anybody know when girls start doing this?
After the first period?
When they're still embryos inside their mom's uterus. Okay? Baby girls start doing this mitosis division stuff right here in their ovaries before they're born, when they're still embryos. Okay, but then it stops before birth, and when a baby girl comes into the world, she has all of her primary oocytes in storage in her ovaries. She won't make any more. Now there are millions of them in there, but she's not going to need them all. But she's coming into the world as a newborn baby with all of her primary oocytes in storage already, and they're in suspended animation. And I'll show you where they are. They're in prophase. In prophase 1, they're in suspended animation in prophase 1. And the chromosomes may even be in the process of crossing over, but they're in suspended animation. When they get to this stage, they stop. It's like they're frozen in action. And they stay that way in suspended animation until puberty. And then when she has her first menstrual cycle, when she ovulates her first egg, ovulation, when the egg breaks out of the ovary, one of these primary oocytes breaks out of the ovary. Call that ovulation. On the average, it happens how often?
Once a month.
Once a month. An egg breaks out of the ovary, enters the fallopian tube. We'll look at some pictures here in a little bit. Once a month, on average, one egg per month. On average, one primary oocyte per month. Now watch this. When this primary oocyte ovulates, when it breaks out of the ovary, that's when it does meiosis 1. Boom! And it splits into a secondary oocyte and a polar body. So what then enters the fallopian tube on its way down to the uterus is this secondary oocyte with a little polar body clinging to it. Okay? So this meiosis 1 happens at ovulation. That's when the primary oocyte, whichever primary oocyte is chosen that particular month, okay, breaks out of the ovary, that's when it does meiosis 1. Now, the secondary oocyte that's moving down the fallopian tube on its way to the uterus, it will not do meiosis 2 unless, we'll use a different color here, unless a sperm cell penetrates it. Okay, there's a sperm cell. Secondary oocytes moving down the fallopian tube, little polar body attached to it. A herd of sperm cells shows up. Well, I don't think they call it a herd, but that sounds like a herd, a flock. A bunch of sperm cells shows up. If one of them penetrates the secondary oocyte, that triggers the secondary oocyte to do meiosis 2. Okay? So here's our fertilized egg. We'll call it an ootid. That's how it happens. Now, I'm pretty sure every male in this building right now, and there are a lot of guys running around in this building, right? I'm pretty sure a lot of guys in this building have done meiosis 2 millions of times. Right, Daquan? Because we're making hundreds of millions of sperms every day. But I would say a lot. I think probably most of the young women in this building have never done meiosis 2. Right? Because that secondary oocyte's not going to do meiosis 2 when it's moving down the fallopian tube unless what happens? Justin? Secondary oocyte, it's not going to do meiosis 2. It's not going to split into an ootid and another polar body unless what happens?
Fertilized?
What?
I don't know.
I think you said it.
Oh, it's fertilized.
Unless a sperm enters the egg. Okay, if a sperm penetrates this secondary oocyte, that triggers it to do meiosis 2. So am I right? There are probably lots and lots of women in this building who have never done meiosis 2. Right? We could talk about my mama. I know for a fact she did meiosis 2 5 times. How do I know that?
She had 5 sons.
She had 5 kids. Now, actually, odds are she might have done meiosis 2 15 times. Because we know that 2 out of 3 fertilized eggs don't make it. they don't result in pregnancies. They may not, maybe they fail to attach to the lining of the uterus for some reason, or maybe the egg dies on its way down the fallopian tube on its way to the uterus. About 2 out of 3. So about 2 out of 3 fertilized eggs don't become babies. Did you guys know that?
Yeah.
About 2 out of 3. So anyway, that's why I say my mom might have done meiosis 2 15 times. And she had 5 kids. So most of the time, if a fertilized egg doesn't make it, if it dies while it's going through the fallopian tube, or it fails to attach to the lining of the uterus, mom never even knew she conceived anyway. She never even knew. She might be a day late on her period or something, but she never even knew. So it's not like a miscarriage where somebody knows that they're pregnant and they lose the baby. It's not like that at all. All right. There's also a real important difference in the size here, obviously. If you take that ootid, that egg, and you make it this big, let's say this big, that would come from a big woman, right? If the egg was this big, she'd probably be the size of the Empire State Building? No, bigger than that. If the egg was this big, the sperm cell beside it would be about like a pencil eraser with a little tail on it. A big size difference.